All right, here's the try it problems for section 6.6. Hopefully you took some time to try these 3 problems all by yourself from start to finish, and you have the same work and answers that I do. For the first one, I'm looking at my denominators. I have a t, and a 5. Setting them equal to 0, I know that t can be anything except for 0. Let's get a common denominator. The first one needs a 5, so I'm going to multiply the top and the bottom by a factor of 5. The second one needs a 5, so I'm going to do the same thing there. And the last fraction needs a t as one of its factors, so I'm going to multiply the top and the bottom by t. Now that my denominators are equal, I can go ahead and set the tops equal. So I have a 15 equal to 20 minus 1t. I can subtract 20 from both sides. I end up getting a negative 5 equals negative 1t, and I can divide by negative 1 and get that t equals 5. Since that doesn't overlap with my domain restriction, t equals 5 should work and be the correct answer for that equation. All right, on number 2, I have 3 fractions. The first denominator is an x minus 2. Second denominator is an x plus 4. And if I factor the last denominator, it also has factors of x plus 4 and x minus 2. That means my domain restrictions are anything except for 2 and negative 4. Let's go ahead and get a common denominator. The first fraction needs an x plus 4. The second fraction needs an x minus 2. And now that I have a common denominator, I can go ahead and work with just the numerators. My numerator now has a 3 times an x plus 4 and a negative 1 times an x minus 2 set equal to x. I can distribute the 3 and the negative 1. I can combine like terms, and I can solve for x. I ended up getting x equals negative 14. And since that number was neither one of my domain restrictions, I know that x equals negative 14 should be the correct answer. That works and makes that equation true. All right, last one. Looking at this one, I have denominators of x minus 3, x plus 2, and if I factor the last one, I have an x minus 3 and an x plus 2. So my domain restrictions are anything except for positive 3 and negative 2. All right, multiplying this first fraction by an x plus 2 because it's missing a factor. Multiplying the second fraction by an x minus 3 because it's missing that factor. The last equation already has both of those factors, so now everybody has a common denominator, and since my denominators are equal, I can worry about the numerators now. My numerators look like this. I can distribute the 3 and the 5. I can combine like terms. I can subtract 8x from both sides. I can then divide by negative 3, and I ended up getting x equals 3. The answer that I got, though, is part of my domain restrictions, and so because that's an extraneous solution, I can't say that x can be 3 because it can't. Because if x is 3, then I have a 0 in my denominator, which we know is not allowed. And so if my only answer is an extraneous solution, then really what's my final answer to this problem? Yeah, it's really no solution. There is no solution that would work that isn't going to cause a 0 in our denominator. So all of that work for no solution. But all that work is important and necessary to work through the problem to actually find that solution. It just happens to be an extraneous solution.